Hello everyone, this is James Shore with another test-driven JavaScript video. I'm recording this on May 20th, 2013. In this episode, we are starting a brand new chapter for Let's Code test-driven JavaScript. So let me start out by just showing you what we've done so far. What we're going to do in this chapter is modularization. We're going to introduce modules into our system. But before we get into that, I just want to catch you up. If you're just joining us in this chapter, what we are working on here is WeWikiPaint, the collaborative painting application. Well, it will be a collaborative painting application. What we have right now is, so far, we've released a marketing homepage onto the web. This is actually online. It's at wewikipaint.com, and it really is nothing more than a little page. However, this page is served by a Node.js server that we wrote and tested. The next feature that we're working on that's not out yet, but is the next feature to go up, is single user painting. So what we have is if we run our application locally, we have the ability to draw on our page. So you can see how we're getting closer to what we need to have in order to actually have a collaborative painting site. Now, this is a pretty ugly page, and making it look nice is on the agenda, but we haven't gotten there yet. What we've been doing to get this single user painting working is we've done a whole bunch of user stories, all tested, of course. Most recently, what we've been working on is getting it working in response to touch events. So if we bring this up on an iOS device, or here we're using the simulator, but you can use a real device as well, it will respond to touch, and actually you can draw on the page, which is pretty cool, I think. So that story is working. It's pretty much done. We're just wrapping up some of the engineering work on that. And then once that's done, we are pretty much done with this feature of single user painting. We'll have some cleanup and refinement to do in terms of making the page look nice and maybe doing some CSS and also improving the way we deploy. But we're getting pretty close to being done with this. The next thing we have to do is to introduce modules. And that is what this chapter is all about. So we've got this code working pretty well, and it's broken up neatly into these three different classes. We've got ClientJS, which is the main bit of code that actually handles the events. We've got HTML element, which is an abstraction of, well, HTML elements to do actual the nitty-gritty event handling and touch events and so forth. That uses jQuery under the covers. And we've got SVG Canvas, which is the code to actually handle drawing the SVG lines, and that uses Raphael under the covers. So these are all nicely split out, but we're using this sort of ugly global namespace approach to make that work. And what I'd like to do before we wrap up work on this iOS touch story is I'd really like to get this using a proper modularization technique. So that's what this chapter is going to be about. Before we get into that, just a little bit of housekeeping. During the break, I updated the NPM modules. You can see the list of them here. If you're following along, go ahead and update to these versions or the latest version. If the latest version doesn't work for you, though, you try using these exact versions, because I've confirmed that these work. Or you can just download the source code using the link under the episode. I've also updated Jake to automatically run npm rebuild. So now, first time you download the code, it will check to see if you've run npm rebuild before, and if you haven't, it'll run it for you. It does that just by seeing if there's a .bin directory, basically. I've upgraded Node.js to the latest version, well, almost the latest version, which is 0.10.6. And 0.10.7 is out at the time I record this. However, it's not supported by Heroku yet. And there's an ugly little bug with npm rebuild where it doesn't work if you don't have a dependencies property, which we don't. So I've updated to 0.10.6. So again, if you're following along, go ahead and upgrade either to 0.10.6 or 0.10.8, which isn't out yet when I record this. But 0.10.7 has that npm bug, which you're going to want to avoid. I've also integrated so you can get the code out of the integration branch. And then last but not least, I had a couple of good conversations about the last chapter. Vlad Gurdiga suggested that rather than using PhantomJS to do our smoke testing, he suggested that we load the web page in an iframe using Karma. And that was a neat idea. And he's provided some example code for that as well. Now, there's some trade-offs to that approach. Check out the comment for the details, but it's really interesting and worth checking out. I'm not going to go ahead and do that now because I'm pretty happy with the PhantomJS approach, but do check out what he's done there because there's some cool stuff. In addition, Michael Spoda, sorry for mispronouncing your name, but he had some comments about the way we're doing our testing in the PhantomJS. He was suggesting that we return the segments from our function and then do regular assertions outside of our PhantomJS in-browser code. Again, I'm pretty happy with the code as we have it right now, but this is something that if you're following along on your own and want to try other approaches, basically the idea is rather than doing our check here, simply return the line segments out of our in-browser function and then use a regular assert here in our PhantomJS code. So if anybody would like to try that and submit a pull request or just share their source code in a gist or something like that, that would be awesome. So thank you to both of you for your suggestions. Some interesting stuff happening there. One other thing, when I upgraded all the NPM modules, I also upgraded to the latest version of Testacular, which is now called Karma. So when you run, if you get the latest code, rather than starting it with Jake Testacular, now you start it with Jake Karma, and you can see that our browsers are all running Karma now rather than Testacular. And there they go. So yeah, if you're just joining us in this chapter, what we have here is not only do we have all this code working, we have the touch events working, we have the mouse events working, everything is working. Not only do we have that, but we also have this all working with just fantastic automation. We're linting everything, we're checking to make sure our online release is working, we're testing all of our server-side code, we're testing all of our client-side code on all of these different browsers, and we're running a smoke test using PhantomJS to make sure that the actual HTML page really does load. So that's what we've been doing up until now. Now, let's go ahead and get into the modularity question. Okay, so modularity. The issue here is that we have our code nicely split out into all these different files, and we're using a pattern that was sort of introduced by Java, the idea of one class per file with the file name being the same as the class name. And I like that approach, so I've echoed that here in JavaScript. But client-side JavaScript doesn't really have any sort of modularization scheme. What we have to do in order to make this work is individually load each and every file in a script tag. And that is pretty error prone. And it's also kind of slow because each script tag is another request to the server. And often in the modern internet, latency is a bigger problem than bandwidth. So each request can take, hundreds of milliseconds to actually go through. So it's often better to have everything bundled together in one file. In addition, to make this work, we're having to do this sort of weird window.wwp equals window.wwp or nothing. This is establishing an empty object as our namespace that's called WWP on our global object, which is window. And we're having to do that over and over again for each file, and that's just going to get more and more clumsy as we go. So I want to use a modularization tool to support modularity on the client. We already have good modularity on the server. You can see here that, for example, in our WeWikiPaint runner, we say require the server. I want to be able to do something similar on the client. There are a couple of different ways of doing this. There are a lot of tools for handling this. Two of the popular ones are Browserify and require.js, and they sort of exemplify two opposing approaches to this modularization question. Require.js uses the AMD, asynchronous module definition pattern. And the idea here is that your code is going to load the files asynchronously. That is, at runtime, you're going to pull down the modules you need as you need them. And it's going to deal with the fact that on the web, once you make a file request, it's going to happen sort of in the background while your JavaScript processing continues on. So the way the AMD code works, let's see if I can find an example of this. Yeah, here we are. The way the AMD code works is you're going to use a require function, pass in the name of the module that you're requiring, and then pass in a callback to be called once that file is loaded. Another approach is the CommonJS approach. This is what Node uses, and it's a somewhat simpler approach. This basically gives us the ability to do require statements directly in the browser, just like we have in Node. So we can just say var, whatever we want the module to be imported into, and then require blah. Now, browsers don't actually work this way. So what Browserify does is behind the scenes, it takes all of your source code and it concatenates it into one large file. And then you just use that file. You include that file directly. So two sort of fundamentally different approaches. One concatenates everything into a single file and gives you a very simple interface. Another is more realistic. It's more about how the web really works, in that it loads each file individually and then gives you a callback. Of these two, I prefer the Browserify approach. It's a little bit more complex from the Browserify perspective, in that Browserify has to perhaps do a little bit more work in terms of concatenating, and it requires a build step. But it's much simpler to use, and it's really similar to the way our Node code works already. Also, because it puts everything into a single file, we don't have the latency question that we would have with lots of separate includes. Require.js, it's a bit more complicated. Some of the reading I've done said that people often start out really liking it in theory, but run into some problems in practice. And it is just a little bit clunkier. It requires more work to get it to work, and you do have the potential problem of multiple calls back to the server. We're not trying to optimize for performance right now, but that is, and I don't know that it's actually a problem. I can't prove it, haven't proved it. But overall, Browserify just seems like it's going to be a little more straightforward for us. So for doing our modularity, I think we're going to go ahead and use Browserify. And so that is what we will pick up with in the next episode, is we'll get Browserify installed and start using it. So this episode, just sort of getting us started on the chapter. Next time, what we're going to do is we are going to install Browserify. We're going to need to integrate it into our automated build. And then we'll need to incrementally migrate our code from the WeWikiPaint global to Browserify's require calls. So that's what's coming up. Thanks for watching, everybody. I will catch you next time.